Hi, George Romanic here. Today we are going to talk about basic trigonometry, sine, cosine, tangent and so on. And I will also describe the relationship between these mathematical functions. To properly understand these, we also need to invoke Pythagoras theorem and write angle triangles, so there will be a nice review of that subject too. Overall, it's a simple video. If you know these things, it is nice to review them in this video. If you do not know, now you know. Let's see what basic trigonometry is. I will start this by saying that right triangles are special. Here is a right triangle. Here is the right angle, 90 degrees. And let's call this side C, this one A, and this one B. Pythagoras' theorem says that C squared is equal A squared plus B squared. But what does this actually mean? That means if I construct a square that has side equal to C, and here I construct square that has side A, and here square that has side B, area of the square drawn from the hypotenuse or C is equal to the sum of the areas of the squares drawn from the two opposite sides. That's the definition of Pythagoras' theorem using words. Now let's call this angle over here alpha. So that is angle opposite to A. Let's call this angle beta, and that would be angle opposite to side B, and this would be usually called gamma, the third angle, in this case 90 degrees. We say that sine alpha is opposite divided by the hypotenuse, and that would be A over C. Cosine of this angle alpha would be adjacent, which is B, divided by the hypotenuse, which is C. I hope now you can see that sine of beta would be opposite, which is B divided by C, and likewise cosine of beta would be adjacent, which is A divided by C. We define tangent, let's say alpha, as the opposite over adjacent, A over B. And likewise, tangent beta would be opposite, which is B divided by the adjacent, which is A. I hope that you can immediately see that tangent alpha is also sine alpha over cosine alpha. We say that cotangent alpha is cosine alpha over sine alpha. We can also use something called trigonometric circle to represent sine and cosine. Let's say I have this nice Cartesian coordinate. I have a circle that has radius r, and that's radius is 1. What are the components of this? Well, this is y component of r, this is x component of r. So we can see, if I call this angle, let's say alpha, we can see that here sine alpha is opposite over the hypotenuse, but what is more important, we can see that sine is projection of this vector r on the y-axis. Cosine is projection of this vector on the x-axis. And we call this region over here first quadrant. And in first quadrant, we can see both x and y projections are positive, so sine alpha will be positive, cosine alpha will also be positive. Now, if we switch here, and this we call second quadrant, we can see that projection on the y-axis will be positive, but now projection on the x-axis will be negative because here is 0, this is negative, and therefore cosine will be negative here. So sine alpha will be positive, cosine alpha will be negative. Now we move here and we call this third quadrant. In third quadrant, we can see that both projections are negative, and therefore both sine alpha is less than 0 as well as cosine alpha is less than 0. And now, without too much talking, in this fourth quadrant, because you can see there is symmetry, in first one both are positive, over here both are negative, here sine was positive, so you can already conclude by symmetry that here sine alpha will be negative, whereas cosine alpha will be positive. But even without symmetry, you can see that clearly because x projection is positive, whereas y projection is negative. Now I would like to tell you that this rule over here for the right triangles, namely the Pythagoras theorem, and these rules can be extended to any triangle. Let's say I have this triangle that is clearly not right angle triangle. We have A, B, C, and opposite angles will be alpha, beta, gamma. We have the so-called law of sines that says sine alpha over A is equal sine beta over B, and that is equal sine gamma over C. There is also the law of cosines, and the law of cosines is the extension of the Pythagoras theorem to triangles that are not right angle triangles, and that one says that a squared is equal b squared plus c squared minus 2bc cosine alpha. As you can see, if alpha is 90 degrees, cosine is 0, and we end up with Pythagoras theorem. Okay, because you're so good subscriber, I will prove the law of cosine, but I will leave it up to you to prove the law of sine. If you are really struggling with that, let me know and I'll make video about that. To prove this, I will drop a normal and I will call this part of the side C y, this over here, and therefore this part over here will be c minus y. So what is b squared? Because now this is right angle, this is now right angle triangle. So what is b squared? Well, that will be y squared plus, let's call this x, this normal, x squared. But what is x squared? Well, x squared is equal to, this is also right angle over here. So that will be a squared, using Pythagoras theorem, minus this over here. But this over here is c minus y, everything squared. So this is further equal a squared minus c squared plus 2cy and minus y squared. So I combine that with this expression, that b squared is equal y squared plus x squared, which is this, a squared minus c squared plus 2cy minus y squared. You can see that y squared and y squared cancels out, and I will get that b squared is equal a squared minus c squared plus 2c, but what is y? That will be b cosine angle alpha. This y is of course b cosine alpha. And this is exactly the same as this over here. You just need, of course, to express this in terms of a to get this result over here. And therefore, I just proved it. That's it. Now you know the definition of sine, cosine. You can go down the street, show off, talk about these things to your friends and family. Until next video, goodbye.